Hello again. Today we're going to talk about compound inequalities and sets. Now what is a set? A set is a collection of objects. Those objects could be things, they could be names, they could be numbers. And compound inequalities, the solution to compound inequalities, are generally sets of numbers. What is a compound inequality? Well, a compound inequality is formed by joining two or more inequalities with the words and or. So let's take a few examples of these. We're given a problem here that says find a solution to x less than or equal to 5 and x greater than or equal to 3. So we have two sets of numbers here. We have all the numbers less than or equal to 5 and all the numbers greater than or equal to 3. So x less than or equal to 5, we could shade all those numbers, and that would be all the numbers to the left of 5 on our number line. And because it has an equal sign, we'll use a bracket right at 5 to say we're including 5 in that set. Now the other set of numbers is x greater than or equal to 3. Well, here's 3. And we have to shade everything above 3 because greater than or equal to. So we're going to go this way, all the way here, going on forever. Greater than 3. And I'll use a bracket again at 3 to indicate 3 is included. So these two sets of numbers here are joined by an and. And then the and means what do they have in common? What is the intersection of these two sets? So and, another name for and, is intersection. What do they have in common? Where do they overlap? Another way of thinking of that. Where do they overlap? And we can see they overlap between 3 and 5. So the solution to this would be, well, x has to be between 3 and 5. The solution is right here where they overlap, where you see the red and the blue. Another symbol for intersection is this upside down U. So all of these and intersection and this upside down U mean the same thing. Our solution is between 3 and 5. And sometimes we write this in a different notation. This is using inequality notation. But sometimes we use what's called interval notation. Interval notation. An interval notation uses parentheses and brackets. Just as I use the brackets here, just like I use these two brackets, we can designate this set between 3 and 5 using brackets. So we would say the set of numbers including 3 and from 3 to 5. So bracket 3 comma 5 bracket, close brackets, means all the numbers between 3 and 5 including 3 and including 5. Let's take another example of this. So we're asked to find a solution to x minus 7 less than 2 and intersect and means the same thing and 2x plus 1 less than 9. Here's my number line. And before we could actually find the solution on the number line, what we have to do is solve these for x. So with this one here, if I add 7 to both sides, we'll get x less than, add 7 to both sides, 9. And here we have to subtract 1 from both sides, so we get 2x less than 8. And then if I divide everything by 2, we'll get x less than 4. So we want to know the overlap or the intersection of x less than 9 and x less than 4. These two here. These two here. Where do they overlap? So, let's graph them. X less than 9, here's my number line. X less than 9 means everything less than 9, so I'm going to put a blue line here. Everything less than 9. Right down to negative infinity. And at 9, instead of using a bracket like we did last time, we'll use a parentheses facing that way. Why? Because we can't include 9. It says less than 9. Strict inequality. Similarly, x less than 4, well, we start at 4. Here's my bracket at 4. Parentheses. And we go all the way down to negative infinity, down to the left side infinitely. And so we want to know, where do these two sets overlap? Where do these two sets overlap? Well, we can see it from the picture. Where do the red and blue overlap? It's everything less than 4. So we would say x, the solution is x less than 4. That's my solution to this compound inequality. We can also do this in interval notation. Remember we talked about that just now? Interval notation, what is that? Well, we're using brackets or parentheses. Kind of like how it's written on the number line. We know our top limit for our solution is 4. And we have all the numbers to the left of 4 going down all the way to negative infinity. Negative infinity. And so my solution is from negative infinity to 4, not including 4, that's why I have a parentheses. And we can never really reach infinity, that's why we have a parentheses around the negative infinity. So there's two forms of the solution to this compound inequality.